So today we are going to discuss about the spanning tree. A spanning tree is a subgraph of an undirected connected graph, which includes all the vertices of the graph with a minimum possible number of edges. If a vertex is missed, then it is not a spanning tree. So a spanning tree is a subgraph of a graph which has same number of vertices, but there should be less number of edges. The edges may or may not have weights assigned to them. A spanning tree has n-1 edges, where n is the number of nodes or vertices. From a complete graph, by removing maximum E minus n plus 1 edges, we can construct a spanning tree. The total number of spanning trees with n vertices that can be created from a complete graph is equal to n to the power n minus 2. Let us take for one example. If n is equal to 4, the maximum number of possible spanning tree is equal to 4 to the power 4 minus 2 according to the formula. N is 4 over here. So 4 to the power 4 minus 2, which is equal to 4 square and equal 16. So if we have given the value of n is equal to 4, then we are able to get total 16 spanning tree from the complete graph. We will take example. What are the general properties of a spanning tree? So the first property is a connected graph G can have more than one spanning tree. Any connected graph G can have more than one spanning tree. Second, all possible spanning trees of graph G have the same number of edges and vertices. So now if we are getting any spanning tree of any graph, the total number of edges and the vertices should be same. The spanning tree does not have any cycle because this is a tree. So tree is free from cycle or loops or any self loops or any circuits. Next property is removing one edge from the spanning tree will make the graph disconnected. That is, spanning tree is minimally connected. So spanning tree is the minimally connected tree. If we remove any edges of the tree, then it will be disconnected. Adding one edge to the spanning tree will create a circuit or loop. That is, the spanning tree is maximally acyclic. So now if we add any edges to the spanning tree, there should be a cycle will create. So this spanning tree is maximally acyclic. Applications of spanning tree. So it is used in civil network planning, computer network routing protocol, cluster analysis. So these are some applications of spanning tree. Let us take some example. Then it will be very clear what is the spanning tree. So find the spanning tree of the following graph. So we have given a graph which has 4 vertices, A, B, C, and D, and definitely it has 4 edges. So we want to find out the spanning tree. So the spanning trees are, first, let us remove this edge. We are getting one spanning tree. If we remove this edge, we get another spawning tree. If we remove this edge, we get third spawning tree. If we remove this one, we are able to get the fourth spawning tree. So these are, just look here, these are the spawning tree which are free from loops or circuits. And now just look here, if we remove any vertices or any edges in this spawning tree, the spawning tree will be disconnected. Let us take one more example. Find the spawning tree of the following graph. Now here we have taken the same graph, but here the edges has some weightage like that. What is the weight of AB? It is 4. Weight of BC is 1. Weight of CD is 2. Weight of DA is 5. So let us find the spanning tree. So the first spawning tree, if we remove this edge, we are able to get the first spawning tree. If we remove, what is the sum? It is, what is the sum of the spawning tree? 2 plus 5 is 7. 7 plus 4 is 11. So this is the spawning tree whose weight is 11. Now if we remove this edge, we get another spawning tree 1, 2, 4, 1, 2, 5. What is the weight of this spawning tree? 1 plus 2 is 3. 3 plus 5 is 8. Now, if we remove this side, then we again get another spawning tree 1, 4, and 5. So what is the total weight? Total weight is 10. If we remove this edge, we get another spawning tree. What is the weight of this spawning tree? So 1 plus 2 is 3. 3 plus 4 is 7. So here we have given only one curve, one graph. Out of this one graph, we are able to get 4 spawning tree. Out of these 4 spawning tree, the which tree has the minimum weight? So the fourth tree has the minimum weight. So we can say that it is the minimal spawning tree. Find the spawning tree of the following graph. So now this is the graph A, B, C, and D. So now if you want to find the spawning tree, what we have to do? That there is a self loop in this part. So we have to remove this self loop. So if we remove first this one, we get the first spawning tree. If we remove this one, we get the second spawning tree. If we remove this one, we get the third spawning tree. So here we are able to get the 3 spawning tree if we are removing the 3 sides of the given graph. So let us take some home assignment for find spawning trees of the following graph. So now this is very simple. Now if you want to find out the spawning tree, there will be 3 spawning tree. If we remove this side, we get 1 spawning tree. If we remove this, we get another spawning tree. If we remove this, we get third spawning tree. So similarly, we are able to get the different spawning tree of the given graphs.